Boa tarde a todos. Sou Tauana Monteiro,
Good afternoon,
especialista em
everyone. I
políticas
am
públicas e gestão
Tawana Monteiro. I
governamental.
am public policies
Meus colegas
expert
aqui, Alan
and also in the
Lopes e Rogério
environmental sector.
Menescal,
With my
nós
colleagues
estamos
Alan
promovendo
Lopes and
esse
Rogério
10º
Menescal, we are
workshop que
promoting this
fazemos
10th
no
workshop
âmbito do contrato
that
que a
we
ANA
make in
tem
the
com o
contract that
Corpo de
ANA
Engenheiros do
has with
Exército dos Estados Unidos.
the
Então,
engineers body of the USA.
boas-vindas a
So
todos
I
vocês.
welcome all
Antes
of
de
you.
começarmos, algumas
And
breves palavras
before
daí
we start,
sobre
just a few
o modus
words
operandi do Zoom.
about how
Muitos
to
de
use
vocês já sabem,
this
mas só
tool.
para relembrar, na
Most of
barra
you already
inferior
knows,
da
but
tela
just
de
to remind you, on
vocês,
the bottom of
existe um
your screen,
loginho
there
que
is
tem
an
que se chama
icon. It's a
interpretação.
globe
Por meio
called
deles, vocês podem
interpretation.
escolher em
Through
que
this
língua
icon, you
vocês
can
querem
choose which
ouvir
language you'd
esse
like
workshop, se em português
to
ou se
hear
em
this
inglês.
workshop, if it is in
Em
Portuguese or in
escolhendo a
English.
opção
Once you
português, eu
choose
sugiro que vocês
Portuguese, I
também
would
cliquem
suggest
em
you to
mutar
also
o áudio
click and
original, porque aí vocês não
mute
ficam
your
ouvindo
original
por
audio.
trás a
Otherwise,
pessoa que
you
está
will
falando em
hear
inglês. Isso às vezes
two
confunde o
voices, the person that
entendimento
will speak in English,
da
and
gente.
sometimes it just
Queria também
get
destacar um outro
yourself
ponto. Nós
confused.
vamos
I also would like to
receber as
highlight another
dúvidas e
point. We
perguntas de
will receive
vocês por meio do botão
questions
também da barra
through
inferior
another
QA.
icon that is on the
Então,
bottom
por
of
favor,
your
enviem as
screen,
dúvidas e perguntas em português, que nós
Q&A
vamos ler
button.
em
So please
português e os
send your
nossos
questions
intérpretes
in
vão fazer a
Portuguese. We will
tradução
read the
por
question in
meio do
Portuguese,
botão
but our
QA.
interpreters will
Vamos
make
deixar o
the
chat para
translation
outros
in
assuntos,
English.
como, por
Let's
exemplo,
keep
o
the chat for
certificado.
other
Então,
things,
falando
for
sobre
instance, the
isso agora, o
certificate.
nosso colega
So
Jean,
talking
que
now
é
about the
da
certificate, our
capacitação da
colleague
ANA,
Jan, that
vai
belongs to the
colocar
training
daqui a
department
pouco
of
um
ANA,
link para vocês
we will share
entrarem
a
e
link
preencherem os dados
on
para o
the chat, and you
certificado
have to
desse
fulfill
workshop.
this
Então, no chat, vamos deixar
to fill
apenas
this
para isso.
form.
Depois ele
So
vai
let's
colocar o
just
link que
keep
vocês
the
têm de
chat only
acessar
for the
e aí sim
certification.
vocês acessem para fazer o
You will
preenchimento
share
para
the link,
depois
you
receberem o
access this, and
certificado
then you fill
de
the form, and you
aqui na
afterward you
ANA.
receive the
Então, as perguntas,
certification.
por favor, por
So
meio do botão
please,
QIA.
questions only in the button
Basicamente, isso que eu
Q&A.
tinha para dizer.
So
Desejo
basically,
a
that was
todos
my
um bom
message. I
seminário.
wish you an
Gostaria de
excellent
convidar
seminar.
agora
Now
Rogério
I would like to
Menescal, que
invite
é
Rogério Menescal,
especialista
that
da
is an
ANA, é
expert
atualmente o
of
coordenador
ANA.
de regulação de seguranças de barragens da
He is
agência
today
e ele
the
vai fazer
coordinator
a
of
fala
dam safety in the
introdutória.
agency,
Só
and
falo
he will
mais uma
make the
coisa.
introduction. And
Peço que
just
todos
one
que
more
usem a
thing,
palavra
I
falem
would like all
devagar
of you
para
that
não
will speak
atrapalhar a
here,
tradução. A
do not
gente às vezes tende a
speed
ficar
up.
muito animado
Sometimes
e
we
falar
get
rápido,
so
e isso
excited and
acaba
speak faster,
prejudicando
and
a
it's just
tradução dos colegas. Então, por
harm
favor,
the
tentem
interpretation. So
falar
please just
pausadamente.
try to
Muito
speak
obrigada.
in a normal speed. Thank you.
Tawana, obrigado aí. É,
Thank you,
agradecer a presença de
Tawana.
todos,
I'd
agradecer
like
aí
to
os
thank you, all
palestrantes,
the
o
audience, all of
Risher
you
e
that are
Leslie
here.
Fields, da
Paul
USACE.
Richard
É uma parceria de
from
10 anos já
USACE.
da
It's a
ANA com a
partnership of
USACE, USACE sempre agregando aí conhecimento nessa área de segurança de barragem, a experiência
in this
deles na
area of
gestão
dam
dos
safety.
empreendimentos que eles
So we have
tentam operar e manter lá e também ajudar os
this
demais
exchange of knowledge with
fiscalizadores
all the
americanos.
things they
Essa
perform there,
palestra
they have there.
especificamente, eles vão
So
apresentar ferramentas
this
para avaliação
specifically, this
de
workshop
riscos de
specifically, they will
barragens e diques.
show some tools
Foi uma
to
demanda
analyze
que
the
surgiu
risks,
do último evento, que a gente foi falar sobre o
and
inventário norte-americano de
it came
barragens, que foi
from the
realizado
last
pela
event where we were
USACE,
discussing
e alguns colegas
about the
demandaram e a
inventory,
USACE
and some
se
colleagues
dispôs aí a apresentar
asked for this
ferramentas, né?
workshop, and the USAC
Especificamente sobre o
offered this
Dam
for us,
Screening Tool,
specifically about
que é a de
the
barragens, eles
dam
inclusive
screening
estão
tool.
com a proposta de fazer um
They are even
trabalho
with a proposal to
para que essa
perform
ferramenta pode
our
ser
work so
aplicável
this tool can
em
be
número maior de
applied and
países, não só
used
nos
in a
Estados Unidos,
higher number
e,
of countries,
e
not
que o
only in the
Brasil seria o
US.
piloto
And Brazil would be
desse
the
teste de
pilot country
ampliação
for this
da
test to
facilidade.
wide this possibility.
Basicamente, eu acho que esses eram os pontos
Basically, I
principais.
think these were the
Agradecer.
main points.
O
Once again,
superintendente Bruno
thank
está
you.
aqui, entrou na sala. Não
Our
sei se ele quer dar
Superintendent Bruno
aquela
is here. I don't know if
palavra,
he
Bruno.
would like to say a few words.
Boa tarde, Rogério. Não, só agradecer,
Good
inclusive, por você
afternoon,
ter
Rogério.
me introduzido. Eu tive um problema
Just to
aqui
thank
no
you
trânsito
for
para
your
fazer,
introduction. I
inclusive
have
agradeço
some
a participação
traffic
de todos e
issues.
principalmente o
I
trabalho do
thank you
USACE aqui na
all your
parceria com a ANA.
participation, and mainly this partnership with USACE with Anna.
Acho que Alan, por
Alan,
favor, Alan, nosso colega Alan,
please, our
tem
colleague Alan,
coordenado aqui também junto
he
à Tawana
has
essa parceria com a
coordinated together
USACE
with Tawana, this
que nos
partnership with
ajuda muito.
USACE, and is the
Perfeito,
person
Rogério.
that
Obrigado.
helps
Boa
us a
tarde a
lot.
todos.
So good afternoon,
Então, eu
everyone.
vou, na sequência aqui, já
And now
chamar o
I
primeiro
will
palestrante, que é o Paul
call our
Risher.
first
Eu vou
speaker, Paul
só
Risher.
compartilhar aqui com
I'll just
vocês
share here
a
with you
biografia dele para
his biography
apresentá-lo a todos.
to introduce him to all of you.
Só um segundinho aqui.
Just one second.
Mais
Paul
de
is
20
a
anos de
hydraulic
experiência em
engineer with
hídricos,
over
tem
20-year
participado de dezenas de
experience in water
avaliações
resources,
de riscos
has
em
participated in
barragens e
dozens
diques
of risk
no
assessment for
USACE
dams and
e
leaves
outras
with
agências. Se
USACE and other
especializou
agencies. He is
no modelagem de
specialized
consequências de
in
inundações,
consequence
cheias e
modeling
rompimentos de
of
barragens
floods,
e previamente trabalhou para
bridges, and
consultoras e
he has
sistemas
previously worked for
locais,
consultants and local
apoiando
governments,
empreendedores de
supporting
barragens e diques. E atualmente
entrepreneurs
ele
of
apoia o
dams and
desenvolvimento
leaves. And
das
today he is
ferramentas de
supporting the
triagem de
development of
riscos
dam and leave
de
screening
barragens e diques,
tools.
que são as ferramentas
That are the
DST
tools,
e
are the
LST que nós vamos
LST and
apresentar
DST
hoje. Então,
that you will
Paul,
introduce
muito
today. So,
bem-vindo
Paul,
novamente. Nós
be
estamos muito
very
contentes,
welcome
muito felizes
again.
com o
I'm
serviço
very
do USACE,
glad
especialmente de vocês
with
pela
Zassi being
disponibilidade.
here and mainly
E
with
passo
your
para você
availability.
a
And now
palavra. Se você
the floor
puder
is
também
yours. If you could
compartilhar sua
also
tela, na
share
sequência eu
your screen.
apresento
So
Woodrow Lee,
after
que
you, I
fará
will
a
introduce
apresentação sobre
Woodrow
a
Lee that
ferramenta
will
para
make the
diques. Nós
presentation
vamos
about
ver
this
primeiro
para
a ferramenta
sticks.
sobre
So
triagem de riscos de
firstly, we will
barragens, a
have
DST.
this
Paul, passo para você a palavra.
screening tool for dams. Paul, the floor is yours.
Thank you, Ellen. And thank you to Anna for this opportunity to be with you all today. Let me know if you can't see my screen. I'll start the presentation here.
We can.
Okay, good.
Perfect.
So we really appreciate the opportunity to be here today and speak with you all from thousands of miles away we're having a late warm summer here in Davis, California, where my colleague Woodrow and I sit, and we're happy to be here. So today I'm going to begin by speaking about one of two risk screening tools that the Risk Management Center is developing. The first is the dam screening tool, and then we'll follow on. My colleague will speak about the levee screening tool. I wanted to recognize a host of contributors also who work on these projects. The first is Jason Needham, who is kind of the technical lead for both of these products. He's been working on the levee screening tool for about a decade, and the dam screening tool since it was first launched about a year ago or 2 years ago. My colleagues Jordan McMaster, Garrett Menachino have had a big hand in this pilot study for Brazil and also in development of the dam screening tool, levee screening tool. I'm not sure if Garrett is on today, but I may lean on him if there's some hard questions. He knows a lot about what's under the hood on these tools. And also our colleagues Gabriella and Clayton, who have worked on this partnership between the Army Corps and Anna for the last few years and presented us with this opportunity. So thank you to all the contributors. An outline for what we're going to talk about today. I'm going to spend a little bit less than an hour talking through the dam screening tool as an overview, and then talking about a pilot study that we did with Anna in Brazil, looking at the results of that study, including a case history for an actual dam failure in Brazil from 2004. And then a little bit about where we plan to go with the dam screening tool in the future. It's still a work in progress, but my colleague Woodrow will talk about the levee screening tool. And that's kind of where we see ourselves going with the dam tool. The levee tool is much more mature. It is fully built out and has been deployed across the enterprise for the Army Corps. And it's in use today across the Corps for hundreds of levees. he'll give you a lot more information about that. And then we'll leave quite a bit of time, hopefully about 45 minutes for questions and discussion afterwards. So first, let's start with what is the dam screening tool? The DST. It's today a rapid consequence assessment tool for flood events. That means that it can make a rapid assessment of life loss and property damage. It's also a web-based application, and most practically, it is just a wrapper for HEC RAS, which is the Army Corps' hydraulic modeling software, and LifeSim, which is our consequence modeling software. Does evacuations and estimates life loss and property damage from flooding. So putting those two together in a web-based application, we have some assistance for the user on developing the input for those two models, and then also some, pretty narrow guardrails on what they're able to build, meaning that it doesn't have full capabilities of those software, but we're using them to create a screening level, which is our lowest level of risk assessment. Now, what do we hope the dam screening tool will become? We want it to become a full risk screening tool. Right now, we can only do consequences, but we want it to be able to assist the user with a full screening. That includes a rapid estimate of the hydrologic hazard, the seismic hazard, if that is a problem in your area, performance under common failure modes, and ultimately from quantifying each of those to calculate the risk. So the results then are displayed in maps and tables and charts, and we're really building off of all of the lessons learned and development that has gone into the Levee screening tool that we hope to learn from with the dam screening tool. So now for a quick demonstration, what does the tool look like? This is a dam some of you may be familiar with, a very famous dam failure in the United States in 1971 called the Lower Van Norman Dam. It failed during the San Fernando earthquake of 1971 in Los Angeles. So we modeled this as something of a case study in the dam screening tool. And here you see the first page of what the dam screening tool looks like. So we have a little bit of information about the dam. We make a link here to the entry within our national inventory of dams. So the Army Corps holds a database of all the dams in the country, federal and non-federal. And there's some pertinent facts about each of those in the national inventory of dams. That's a whole different tool. But we have a link here and we can pull in that information, which includes dam height, how long it is, the storage in the pool, some important information that we can use for the screening. So you see here we have one tab available for analysis, the consequence tab, and I'll show you what that looks like. So what this tool is going to do first is create an inundation model using HEC-RAS. We're going to import a structure inventory, which is all of the buildings within the flooded area, including the population that live in those buildings. We're going to set up the LifeSim model, and then we'll have results. So here you can see where the model is set up. The bluish purple area is the model domain. And here we've set up that model with 500-foot grid cells. I can't do that conversion in my head at the moment, but let's say about 125 meters or so. We've also added some break lines and the dam itself. So the dam is up here at the northern end of the model. And just a little bit of information about the dam. We know the top elevation is at 1,145 feet. And we're going to restrict the cell size to about 200 feet near the dam to help the hydraulic model remain stable. We also have these break lines in here. So what we're going to do in this blue area is create a hydraulic mesh. And so you can see here what that mesh looks like and how these break lines influence the mesh by aligning with it. So this is the two-dimensional hydraulic mesh for the hydraulic model. And we're enforcing these break lines because they are along highways which are raised several meters above the ground elevation and really are directing the water by causing ponding in this area and, you know, forcing the water through underpasses in the highway. So those were important to included. I'll show you here what the hydraulic model looks like. You can look at it in terms of a maximum depth, or let me turn some things off so we can see it a little better. We can animate that model from the dam breach as the flood moves through the populated area. Hopefully that's coming through in the broadcast. I'll run it once more. So I think this is really powerful, and we'll talk about some of the other uses of this capability as we go on through the presentation. So we have the ability here to import terrain directly. We call it DST terrain. Really, it's our US Geologic Survey has a national data set of terrain available for the whole United States. And that information is at 10-meter resolution. We can import that directly based on the area that we've selected for the model. Or we can do a user uploaded terrain. And that's what we've used in Brazil so far. You can get that terrain from anywhere, manipulate it how you like outside of the DST, and then upload it here. We also have the ability to modify the terrain using the break lines. We'll sample the terrain underneath those break lines. And then you have the ability here, for example, we saw a low spot in that road that didn't actually exist. And so we raised that from what was elevation 684 up to 705. So we have that ability to manipulate the terrain for better hydraulic results. Then we're going to create a flood scenario. We see down here, we have a couple options for how to do that. We can input a user-defined hydrograph directly just by entering the flow underneath the dam or below the dam with a hydrograph. Or we can actually model the breach. If we assume there's a storage area above it, then we need to give the DST some information about how much water is stored in this relationship. We need to say that the reservoir is at a starting elevation. Then we can have inflow to that reservoir. We turn this off if it's a sunny day failure. We can have a spillway or gate outlets with an elevation flow rating curve. And then we have the ability to model the breach. So this is a really cool feature. We have some built-in kind of helping assistance from our FEMA kind of, there's a table here of what the FEMA guidance is for how to model a breach. Or you can just, if you have a better understanding, you can enter your own information over here on the right side. And we even include a regression calculator using some common breach methods here: McDonald, Language Monopolist, Froelich, Von Thun, Gillette, and Zhu and Zhang. So these are standard in HEC-RAS as well. So all that information comes together to define the breach, how wide it opens, how deep it is, and how fast that breach occurs. All very important for determining the hydrograph. So once we have that hydraulic model running, we're going to import a structure inventory. This is a large one because it's in Los Angeles, very dense urban area. This again is a national data set developed by the Corps of Engineers. We have a point for every structure, hopefully. It's not perfect, but it's pretty good information. And we have information about what it's made out of. This is a wood framed structure. It's residential, it's 1 story tall, and it has this population over and under 65 during the nighttime and this population during the daytime. This is how much it's worth and how much the contents in the vehicles at that structure are worth. So all that information is really useful for the consequence model. This is the basis really of the life sim model. Then we have a couple questions to set up the life sim model here. Information about how the evacuation planning would happen, the community's awareness of the risk from flooding, and how effective they think the warning will be. So just a couple, drop down lists here of those, and that they manipulate these curves here, which dictate how fast the population receives a warning and then reacts and begins evacuating from that warning. The last piece of information is how much advance notice is available before the breach occurs. Are you able to predict that breach or observe some warning signs beforehand and give some time to warn people in advance? And then the results are here. You can see for this failure, we got a pretty high life loss, somewhere in the order of 2,000 to 3,000 or 1,000 to 3,000, depending on time of day. We can look at the population at risk. We call it the PAR often. Over 100,000 people, 150 to 160,000 roughly. And a fatality rate of about 2% gives us a life loss there of 16 to 2,700 on average, and about 45,000 structures inundated. So luckily this dam, when it failed, it was the pool was low, and so when the crest collapsed and the dam failed, it still luckily was above the level of the water in the dam. If the dam had been full that day, as it had been a couple years before, it could have been very catastrophic results. So that is the dam screening tool in a nutshell, what it is today. I'll move on now to talk about the pilot study. Some objectives of this study: first of all, we wanted to know, can we really use this dam screening tool outside of the United States? The US is, let's say, a little stubborn about our use of imperial English units. And so we're not always sure when it comes to metric, if that will be an easy conversion. And there's also the question of availability of data outside of the US. So we wanted to know, could this actually be done in Brazil? And then what benefits might it offer to ANA and the dam safety community in Brazil? It has the potential, we thought, for floodplain mapping, for emergency planning, potentially hazard classification, and ultimately the goals for our development of the tool: life loss and damage estimates, and eventually, with full build out, a risk screening. We anticipated some challenges along the way. There's always this trade-off between speed and accuracy of the modeling. So we can get a very rapid result, but is it good enough to make any kind of decision with what kind of availability would we have for data? We know that there's a global 30-meter terrain data set, and would that be suitable in Brazil for this type of modeling? And how are we going to come to get breach hydrographs? That's always the challenge with the hydraulic model, is how do you model the breach? It can be very sensitive, and so we looked at a couple different ways to develop those breach hydrographs. Okay, so now specifically about how we develop the input within Brazil. When we're doing a life loss model, this is a typical flow that we go through to develop any life sim model. The first is trying to understand the initial distribution of people. So where do they start in the model? And then we redistribute them, meaning we warn the people that there may be a flood coming. How do they respond to that? Do they evacuate? Are they not able to evacuate? Do they not get the warning? We try to understand that. So this first distribution of people, I mentioned the national structure inventory. So we have to figure out how to do that in Brazil. Then we're going to redistribute the people. And that is, luckily there's some research, social science research about how evacuations happen that I think is applicable in any location. And that's built into LifeSim, and we will use that in Brazil as well. Then we want to understand the flood. We're going to do that in the two-dimensional HEC-RAS model. The model is dependent on underlying terrain, the ground surface, and the roughness of that terrain, which is typically modeled with a land use map. All that information will give us the arrival time of the flood, which is critical for understanding if the evacuation is effective or not. And then depths and velocities to understand if people are still there, what hazard are they exposed to? Then we want to know if they are still there, what kind of shelter is provided by the building that they're caught in, or the vehicle, or if they're just out on foot walking. So those assumptions are also built into LifeSim, and I think they have an international applicability. So my colleague Jordan McMaster that I mentioned did a pretty amazing effort, I think, to pull together a structure inventory for all of Brazil. We've termed it the BNSI, the Brazilian National Structure Inventory. It basically tried to put a point on every structure in the country the way that we've done it in the United States. We didn't have quite as much information available, but the location information was pretty good. And then we attribute each of these points in the inventory with some information needed for the model. So we want to know what is the building being used for? That's the occupancy type. Is it residential or commercial, multifamily, single family? How tall is it if people can get above the flood? What's the construction material? How high is the foundation that raises the structure out of the floodwater? And then what is the population, daytime, nighttime, and elderly and below 65 population? And then how much is the structure worth? Things I mentioned before. So we struggled with some of these, had a little more success with others. So first of all, the location was set by Google's Open Buildings. It's a global data set. It included about 129 million structures in Brazil. This is mostly an AI, artificial intelligence, using whatever information Google has, elevation, aerial photos to ascertain whether a structure is located there. And that data ended up being pretty good for us. It matched pretty well with what you see here of real structures. So that was the base layer. Then we added the population. This was based on 2021 census data from the Institute for Geography and Statistics. We used age 60 as a dividing line. In the US, we have 65 as our limit between, normal aged and elderly. In Brazil, I guess that's more like 60. So we use that as instead. And then we have the structure and the vehicle values using a cost per square meter estimate from this national index, and the vehicle values using just average estimates. So that left several fields with not very good data. We had to make assumptions for those. So we assumed every structure is a single family residential structure, 1 story tall, made out of wood, and assumed to be 0.15 meters of foundation height above the ground. And then the content value is 50% of the structure value. The terrain, we wanted to test the difference between a 30-meter terrain and better quality LiDAR. So Anna provided us with some LiDAR. This is an example for one dam in the pilot study, Negreiros Dam, where we had a small area of 1 meter DEM and we supplemented with 30-meter DEM for the rest. So in actuality, the 1 meter DEM was probably too good for hydraulic modeling. And so we downsampled that a little bit to a 3-meter resolution to reduce the file size. But also we found that that resampling didn't impact the hydraulic results very much. Where we were missing the 1 meter data, we supplemented with 30-meter. And we also used another worldwide data set, the World Cover 2021, which is land use and maps of vegetation types and things like that we could assign a Manning's and roughness parameter to in the hydraulic model. So here's our 2 data sources down here for those global data sets. Looking at the differences between those DEMs, here's a cross section on a river. You can see the low res terrain, may be a little bit shifted. It may have some differences between the higher res terrain, the darker blue. But the important thing here is the difference between the 1 meter and the 3 meter where we downsampled is barely visible. Those are the 2 dark lines together. So we noticed in the 30-meter that some of the channel, these deeper parts of the channels here may not even register in the 30-meter. So it may underestimate flood conveyance, which can lead to overestimating consequences. It lacks some detail. I think it's also important to note that the DEM, the 30-meter is actually a digital surface model. So at times buildings and treetops can get in the way of that terrain because it's bouncing off of those from space. It's not sampling the true ground, which the water will be flowing on, but it at times bounces off trees and rooftops, which can be problematic. Okay, so we have a couple options for breach hydrographs. And one of them was this very simple approach with a trapezoidal hydrograph using very little information. We're able to develop this hydrograph. We can basically use a regression equation for the peak flow. So here there's a peak flow based on just a couple things, the height of the breach, the height of the water above the bottom of the breach, so those 2 heights, and then the embankment width and the volume of the water above the bottom of the breach. So just a couple things about the reservoir and the dam, we're able to estimate a peak breach outflow from an embankment dam. And so we did that. And then with a little trial and error, we can manipulate these 2 times, the peak time and the total length of the hydrograph, to roughly estimate the stored volume in the reservoir in the breach hydrograph. So that's how we developed those for the dams in the pilot study. Well, there was one concrete dam, and so we had to use a different equation for that one, but basically the same process. We also wanted to look at modeling the breach explicitly using parameters of the breach that describe the geometry and this, how fast it opens. So we get a more realistic breach hydrograph and use that function that I showed you before with the breach regression calculator. So we put in a little information about the dam and the reservoir, and we get some regression output here, and that's what we use to develop the breach hydrograph in those cases where we model it. So here are the results from the development of the hydrographs. We looked at 4 different dam breaches. You can see them there on the left. These were the peak results that developed the trapezoidal hydrograph with those times. And then we modeled 2, Ipanema and Fatima. And this is the difference. So you can see the peak is a little bit higher in each of those, but it is much more rapid that we reach the peak. It's much steeper hydrograph, and it comes back down very quickly. But the peak is higher. So we'll see the impact of that. Okay, so now into the results. The Ipanema Dam. We looked at a few different scenarios. High resolution versus low resolution terrain. This is the 30 meter and the 3 meter using this trapezoidal peak regression hydrograph. And it resulted in very similar population at risk, a little bit higher for the high resolution, and number of structures flooded, a little bit higher. The PAR, if you're not familiar, that is the population of people at risk. So how many people are located in those structures that get wet? Interesting thing here, though, is that the life loss decreased between the low resolution and the high resolution. So what happens when we look at the high resolution terrain between the 2 options for the breach hydrograph? We can see that the population impacted decreased, the life loss is about the same, and the number of structures flooded decreased. We also had some floodplain boundaries, this orange boundary here, that were provided by ANA from their previous work. And so we were comparing against the work that they'd done previously, and what their floodplain would show is similar to our low resolution results in this case. But we do show that the floodplain is a little bit more narrow with the higher resolution results. We also extended the model quite a lot beyond what ANA had developed previously, looking for where this may be impacting people further downstream. So life loss is less of a concern downstream, but property damage can extend well beyond this area, and perhaps life loss as well. So this was not a very exciting one from an impacts perspective. It pretty much stays within this channel. There's a couple of areas of where structures are close to the river that get impacted. This next dam had a lot more interactions with population and structures. You can see here we looked at low res versus high res terrain. Negreros actually has 2 dams. One is a concrete RCC dam, and then Saddle Dam is actually a earthen embankment. And so we looked at the breaches from both of those and how they might impact different populations. You can see in the high res terrain here the difference between those breaches. There's the population at risk is pretty similar, but the life loss goes up considerably when the embankment fails versus the RCC dam. And you'll see in a minute why that is. The people are located more closely to the embankment than RCC. We also have quite a bit more population at risk and structures flooded than the ANA floodplain, and that's because, again, we extended our floodplain much further downstream than theirs, and so included many more structures downstream. Here you can see the difference. In the orange, again, is ANA's floodplain, and then the blue is our 2 floodplains extending from the RCC dam here on the left of the reservoir and the embankment dam on the right. So we've got, the 2 floodplains are combined, they're overlaid on each other. But there's a lot of population in this area that could be infected by that, or affected, sorry, by a breach of that embankment. Whereas if the RCC dam breached, they're not really touched in that area. This is an example of the life loss map and where we're seeing a high life loss. It extends quite a ways beyond the limit of the ANA floodplain, which was, I think, about 10 kilometers. We extended this model for almost 100 kilometers, I think, including passing it through another dam further downstream, Terra Nova Dam, and found that there was potentially a lot of interactions below that area. The third dam that we looked at in more detail, again, it pretty much stayed within this channel. Looking at the difference between the high and the low res terrain, we see an increase in population, an increase in structures flooded, but basically the life loss is the same for each. And then between the breach methods, the modeled has a lower life loss. So looking at how did the DST work with the 30-meter terrain? Comparing all of these dams, we saw some trends in the results, and that was that higher resolution resulted in more structures being flooded and a higher population at risk, but a lower life loss or the same life loss in every case. So you can see here that those trends. PAR goes up, life loss goes down. We think that's probably due to better definition of the edges of the flood, so that we're including more people with just a little bit of water, but we're getting more accurate depths throughout the floodplain, because typically people are building their houses, you know, a little higher up out of the floodplain, but the 30-meter DEM may not be capturing that. And so it has, you know, one water surface across there that's not providing good resolution in the depths. So we're seeing better resolution, more accurate depths, and therefore a better estimate of the life loss. But interesting to note here is that these are pretty close, basically in the same order of magnitude. And so from a screening level approach, the results are not that far off. Some issues we encountered in the 30-meter terrain. This is one where there was a dam located in Terra Nova. Probably would have backed up the flooding a lot more. It was not captured in the 30-meter terrain at all. So the flood just passed right through and ended up flooding a lot more here. So there's two ways this could have gone. You know, maybe that dam would stop the flood from continuing on, or maybe it would be overtopped and fail and contribute more water downstream that had been stored behind that dam. So hard to know there which way that would have gone, but some error in our estimates for sure. Here we saw a problem with the age of the 30-meter terrain. There was a new structure built at Terra Nova as part of a large water conveyance project, and it was not represented at all in the terrain. So the flooding kind of went on both sides of it without any interference. And you know, that's just a problem with how old that 30-meter data is versus the age of this project. I think it was built in 2016 or 2017. So we spotted several instances of hydraulic issues. And so in running this model, it's still good to have a hydraulic engineer be able to look at the results and assess whether or not they're reasonable. We saw some disconnected flood areas. You know, that happens when you have grid cells that are too big and water can just kind of skip between cells. We've got to make sure that there's proper representation of linear embankments, which really, you know, direct the flow, especially elevated roads, railroads, and levees. There could be inadequate terrain or bathymetry. So you can see here a couple cases on the right where the trees here are poking out of the floodplain because it's a digital surface model and they are a higher elevation when they probably shouldn't be. The floodwater should probably be able to go straight through there. In this location, it probably doesn't matter at all, but in some locations that may be more important. We noticed the sequential failures, as I mentioned. Getting a realistic breach hydrograph can be important. That the simplified hydrograph of using a trapezoidal hydrograph may not be very realistic, and so that may require the input of a hydraulic engineer to develop a better one. And then we're having some issues with the computational model, getting the time step correct, looking at momentum versus diffusion. That's some of the technical stuff under the hood in HEC-RAS. This would be a more intense computational solution to use full momentum versus just a diffusion equation. Getting the correct roughness, Manning's roughness in the model. And then just looking at the results in general, are they reasonable? Are we getting stability errors that are making depths and velocities crazy? Sometimes you need a hydraulic engineer to be able to assess that. Okay, so we've got those results. We wanted to add some ground truth to whether or not those results are decent at a screening level. And so we looked at this failure that happened and where was it? Paraíba State, sorry. Had a bit of a brain lapse there. This was Camará Dam, 2004 it failed. It was a roller compacted dam. And so we looked at this in the dam screening tool. Cool. This is what it looked like shortly after it was completed in 2002. It had some problems on the left abutment with a foliation in the rock that wasn't noticed. They did some treatment on part of it, but it extended much higher up the abutment than they were aware of. And so that's ended up being where it failed. We got some pertinent data from this paper down here by Barbosa and others that they looked at the failure right after it happened, and so provided a lot of good information that we could use to build the model. We learned that it was not full when it failed. It was a sunny day failure. There had been some storms that filled the dam to a new record pool, but this pool was still well below spillway crest elevation, several meters below spillway. So it was not full, but we got enough information to build a capacity curve to know how much water was in there at the time of the failure. Then this is what the breach looked like. It was an oddly shaped breach. It popped out this section of the dam like a cork out of a bottle and took a piece of the abutment rock with it, and it just slid out. It was a very loud failure apparently when it happened, and it was witnessed by a couple people at least who tried to warn those downstream. So I attempted to model the shape of this in HEC-RAS and to try and develop a breach hydrograph from this failure. So we got some measurements of what that breach looked like, kind of assumed it was somewhat of a rhombus shape, and then turned that rhombus into a rectangle and tried to get that into HEC-RAS, and more or less successful with a 12-meter wide breach, 30 meters tall. There was some scour below the foundation elevation that we weren't able to model in HEC-RAS because we can't do scour, but so the blue area is what we actually modeled. And it looks like this in HEC-RAS. The red is our actual breach in the model, and the gray is probably what it should have looked like. This was the breach hydrograph. And then this is the results from DST using the 30-meter DEM and that modeled breach outflow dropped in below the dam. So the location of the biggest damages was in Alagoa Grande. And this is the city here showing the flooding. You can see it impacting some of the structures in this area along the river. And we had some information about what was flooded. No maps, unfortunately, but there was a list of the roads that were impacted with structures that had either been damaged or collapsed from the flood. And so overlaying those roads on the flood map, you can see that we're doing a decent job of getting the impacts to the right streets. Some of those streets were very long and it was just a portion that was impacted. So you can see there's like this whole area over here where only a portion of the street was actually impacted, but the whole street shows up in this map. So doing a decent job. Basically, the flood came through the middle of the town and into this small pond and along the river where the major damages occurred. We learned from that paper also that there was a total life loss of 5. 3,000 people were in homes that were damaged, in a total of 810 homes damaged or destroyed. Here's our results from the DST. We have a population of about 1,800, so we're underestimating there. But we're overestimating the life loss by a bit. We got about 50. And a total number of structures, 738 structures. So a little bit low on that estimate as well. Here's our results looking over the whole range. So LifeSim, I hadn't mentioned before, does a uncertainty sampling using Monte Carlo analysis. So it looks at many different options for warning and evacuation times. And so these are the results of 1,000 simulations with an average of about 50 life loss and a range from 3 up to almost 100. So looking at some of our assumptions here is the actual life loss about 5 and our range here from about 3 to 100. So we're overestimating here. One of the reasons for that is that we are making really pessimistic assumptions about the evacuation because we have no information about the evacuation planning or the community's risk perception. We sampled a wide range. But you can see here the trend that with a better evacuation, we're doing closer to the actual. And the other thing you're seeing is there's a big range here of other factors that are impacting this. And that includes the amount of advanced warning that's available, how much time there was. And this x-axis is showing how many people or what percentage of people are actually taking evacuation actions. And so on the right is about 95% and on the left is about 35%. We're also seeing this map here. Alagoa Grande is this area that's showing up red. This is where we're seeing the highest concentration of life loss. But we also have this whole region through the canyon of the river that's showing high life loss. And there weren't any reports that I found of life loss in that area. So I think people did a better job evacuating there just by word of mouth to get out of harm's way very quickly. So on all, they did a much better than our average estimate of evacuation. So that's what we saw from the case history. So where is DST going? Talk now about just kind of where we hope to go with this. Ultimately, we want to be able to estimate risk from A to Z at a very base level, what we call our screening level assessment. It's not a lot of detail, but hopefully it's enough detail to be able to understand, relatively speaking, is this a higher risk dam or a lower risk dam? And in order to do that, we need this information to be able to quantify the risk. We have to understand the hazard, the probability of the hazard, the probability of poor performance of the structure. So how likely is it to fail? And then the consequence from that failure. So this is the setup for levees. It's already been implemented in the levee screening tool that Woody's going to talk to you next. This is where we hope to go, getting each of these pieces of the equation together in the dam screening tool. So we currently have one tab in the DST. This is what the build out looks like in the levee screening tool: hazard, consequence, performance, and then the risk computation and some results maps. So that's where we're hoping to go. And I'll turn it over now to introduce my colleague, Woodrow, to talk about that tool.
Thank you so much for the presentation. I'm going to introduce Google, and then after Rogério, we can make the questions, okay? Yeah, it's better to follow, and then we have questions at the end.
So just to introduce here, Dr. Woodrow Fields is consequence specialist with the USACE Risk Management Center, has more than 15 years of experience working with the corps, is specialized in consequences assessments and risk. Woodrow is the lead developer of LiveSim, which is a detailed consequence modeling system for estimating economic damage and life loss through simulated warning and evacuation combined with flood wave propagation. Woodrow is also co-developer of RMC Total Risk. It's a risk analysis software package designed for dam and live safety. Woodrow has obtained a BS in Environmental Science from Portland State University and MSc in Civil and Environmental Engineering from the University of California in Davis in 2009. So I'd like to welcome Woodrow. Thank you. We are very happy for having you here. So let's talk about the two paradox.
Great. Thank you, Alan, very much. And thank you for everybody for the chance to present. I'm going to go ahead and share my screen, and then I'll start the presentation that I have for you all on the levee screening tool. So hopefully you can all see my screen now. If I can just get a verbal. Verbal.
Yes.
Okay, great. Thank you. All right. So this will be pretty quick. Paul Risher did a great presentation on the dam screening tool and how we're applying that both here in the United States and down in Brazil. I'll be talking about another tool that's using the same fundamental computations, the levee screening tool, which we've designed for levees in the United States. So why do we need a tool like this? After Hurricane Katrina, which happened in 2005, the US government pushed forward a big effort saying, hey, we want to know how the risk of our levees in our nation. So there was a safety act that went forward by Congress that authorized the Army Corps of Engineers to do a one-time risk assessment and inspection for every levee in the United States. Now, there's a lot of levees in the United States. As you can see from this plot, there are over 4,000 miles of levee that just the Army Corps of Engineers operates, over 15,000 miles of levee that we know about that are non-core, and then an unknown number of miles beyond that. So there's a need for a tool that can quickly and accurately portray the risk so that we can rack and stack our portfolio of risk assessments and projects and identify which ones are the highest risk so that we can invest in those ones first. The screening tool is designed to get a better understanding of what's driving risk for a levee system with minimal effort going in. Because we have so many levee systems, We need a tool that's going to be able to accurately portray those risks without breaking the bank, without putting together massive hydraulic model and consequence assessments and umpteen thousands of dollars in performance mode assessments. We need to be able to do that much quicker and cheaper. Beyond that, we need to be able to go on and take the results of these efforts and share them with local and state partners so that non-federal levies and levies that are made their risks and aware of the findings that we have so that they can take efforts to improve the safety of those living behind the levees. So I talked about what the need is for it and kind of the overarching goals of the levee screening tool, but what's in it? What is in the actual tool itself? To do the risk assessment, we need to provide a hazard function that gives a return interval. How often is this levee going to be loaded with water? The performance of that levee when it is loaded with water, when there is water in the river loading that levee, what's the probability that it could fail due to various performance modes? And then if that levee fails, what are the consequences associated with that failure event? We need these three fundamental pieces of information to be able to do a proper risk assessment. Some of the data requirements to start a screening: we pull information from our national levee database in the form of a levied area. That levied area represents all the area that levee is protecting. And if flooding were to occur, if a failure of that levee to occur, everything within that area could potentially get inundated. We use that levied area as a foundation starting point for our hydraulic model as the two-dimensional hydraulic mesh. The second piece of information we get from the National Levee Database is the levee alignment itself. It's a line shapefile and geospatial line in space. And along with that line in space, the XY data, we also want the Z data, the vertical elevations associated with that levee. And then from other national data sets, we pull terrain and land cover for our hydraulics, national structure inventory for structures and population distribution, and then critical infrastructure. The hazard loading function is defined by the user in the tool. And the minimum required information by the user is what's the return interval of flooding to reach the levee toe? What's the return interval to reach the top of the levee? And then 3 feet above the levee. Those are the requirements. And then everything in between would be log linear interpolated. However, if there is more information available, then the user can go in and define the hazard function however they want. On top of that, you can enter multiple hazard functions throughout your levee segment. An example of this might be in a coastal situation where you have the upstream land side of the levee loaded primarily by the river, and the downstream side on the estuary loaded primarily by the coast by wind wave action. You can have different loading functions to represent those different loading scenarios. Now we get to the performance piece of it. In the levee screening tool, we have a predefined number of performance modes, of failure modes, potential ways that the levee could fail. Depending on the type of levee system, you'll select from those failure modes that are common for various types. For example, if you have an earth and embankment levee, then you have 4 performance modes that you can assess: backward erosion and piping, slope stability, riverine erosion, and concentrated leak erosion. These are different failure modes that you can assess at locations along your levee system. If you have a flood wall, there's 2 flood wall failure modes that you can assess. And if you have closures, then you can assess the probability that that closure does not get installed in time or gets installed inappropriately and fails. And then finally, the final failure mode that we're including is overtopping with breach. As we saw during Katrina, many levees overtopped, and that overtopping led to a failure of that levee, pushing a slug of water into that levied area and causing excess life loss. That probability of failure when overtopping is assessed in the levee screening tool. For each of these failure modes, the user enters in their likelihood of an event occurring using the event tree structure to look at probability of failure. And by event tree structure, that means that we're looking at the sequence of events that lead up to the failure of the embankment of the levee. For example, if you have backward erosion and piping, that is going to initiate at some point, depending on your embankment materials. That initiation can progress into a seepage pathway. That progression can continue and continue growing until eventually it breaches. These sequence of events, each component of that sequence is assessed individually through an event tree. And the user, the assessor, will assign the likelihood of each of those events occurring. And that comes up with your quantitative probability of failure by assessing the probability of each of these nodes occurring in the sequence that leads up to that failure mode. Once that's assessed, what's the probability that this levee is going to fail due to this failure mode when loaded to the top of that levee? A curve is then fit to that. A curve is fit to that probability of failure at loaded to the top, based off of what we have as an incident database of thousands of levees throughout the nation and their history of loading, and if they failed or not. But not only that, how they failed. So we use this database of levee loading events to inform the probability of failure as we go below the bottom of the top of levee. So we fit a distribution that simulates the conditional probability that this levee fails at various loadings of that levee. So probability of failure at 50% loading of the levee, probability of failure when it's loaded to the top, and then even extending beyond the top, probability of failure when it's 1 foot above the top of levee. That's the performance piece. Now the consequences. I think you all have a pretty good understanding of how the consequences work in the levee screening tool because of Paul's presentation on the dam screening tool. In the levee screening tool, however, there's multiple scenarios for each location where you define a breach. And those multiple scenarios are, what are the consequences if the breach occurs at 25% loading of the levee, 50% loading, 75%, and to the top? Inputs are similar to with the dam screening tool for terrain and land cover, national structure inventory, critical infrastructure. All of this information is coming in from national data sets, just like with the dam screening tool. Hydraulic data is developed using HEC RAS, and the life loss and economic damages are estimated using LifeSim. So it's the same underlying computation engine that's producing the consequence estimates as in the dam screening tool and some of these other tools. Structure inventory, as you saw before, comes from the National Structure Inventory. There's a lot of tools to easily view, modify, download, and upload a structure inventory for the study area. As I said, the 2D hydraulics are coming from HEC RAS, where you get an estimate of the maximum depths that are occurring in your levied area, along with the time series of depths and velocities that are occurring with the levied area. The results of this analysis go beyond just the consequences, beyond just what's potential loss of life, what's potential economic damages. Because it's a full-on risk assessment, we can get a lot more information out of the analysis. For example, we can look at what failure mode is contributing to the annual probability of inundation? Is it due to overtopping without failure, meaning it really doesn't matter if the levee's there or not? It's loads, it's a 1 foot tall levee or a half a meter tall levee, and it's just overtopped all the time, and the consequences are going to be there no matter what. The incremental consequences are very low. Or is it the annual probability of overtopping with breach? Is the failure really contributing to the overall probability of inundation here? So we can start looking at what's contributing to the probability that people are going to get flooded. And then on the plot that I just showed you here is what we use primarily for our decision making in the Corps of Engineers. On the y-axis is the annual probability of failure. Each of the circles in the plot represents a failure mode, the risk analysis for an individual failure mode, and the square represents the total incremental risk associated with that levee. So the annual probability of failure on the y-axis, the x-axis is the average life loss that is expected to occur given a failure. So if we look at this individual system, we can get an estimate that the annual probability of failure is between 1 in 100, 1 in 1,000. And the average life loss given a failure occurs is going to be between 1 and 10. We can then rank that against other levees in our portfolio to get a sense of which levees have the highest probability of failure and which levees contribute most to the potential for life loss. And then we can start addressing those first and fixing those levees first to reduce the overall risk across our entire portfolio of levees. Some other risk nuggets that come out that are really useful are the total flood risk. So the previous risk was looking at the risk imposed by the levee structure itself. And that's what we care about as an agency that's managing this levee. But for those living behind the levee, what they care about is not just the risk imposed by the levee itself, but what's the risk of flooding due to any means, natural flooding, levee failing, any means whatsoever. That's where we have these flood risk metrics. These flood risk metrics are very useful for those living in the communities downstream because it's telling them what their risk is due to not only the levee, but the risk associated with them just simply living in that area. And then the tools in the levee screening tool can help to assess which of those two risks are the primary risk drivers for these communities. Is that risk due to the levee and the levee's failing, or is the risk primarily due to non-failure, where those people are going to get inundated regardless of the levee being there or not? These are all really great tools that we can use in the United States for looking at our portfolio. And these are really detailed analyses that we can do at a screening level. But one of the most important pieces of this entire process is the review. Built into the levee screening tool are multiple levels of review to ensure that those risk estimates, those life loss estimates, the return intervals associated with the flooding, the loading of those levees, the probability of failure given those loadings, those need to be reviewed to ensure that those risk assessments are relatively accurate. And so we have this review process of multiple tiers and national groups meeting and analyzing and assessing the risk analyses, and then allowing to kick back for refinement and then send back up the change. So multiple levels of review are critical in the success of this program. There's two steps in that review process that require a presentation to a group of experts. One is a national cadre reviewers, a national group of experts that's going to review it, provide a more detailed and thorough review analysis, and a lot of comments on what can be improved, what can be fixed, essentially like an agency technical review. Then the second group level review is a senior oversight group level review, where these senior experts will again review it and then potentially send it back for comments before it finally gets that stamp of approval and getting sent on. The screening tool was designed so that it's easy to navigate within the user interface, so that those who did the risk analysis with the tool can present directly from the web interface. And that makes it really nice for the group to be able to dig down and identify what's driving the risk for these individual systems that are being analyzed. Finally, some of the standard operating procedures and policy highlights from all of this effort. One is that the screening team needs to be coordinated and collaborative. It's not just one engineer doing the work generally. For a levee screening analysis, you want somebody who's going to be an expert in hydrology and looking at rainfall runoff and frequencies of loading. You want an expert that's going to be strong in geotechnical background, understanding what leads to the probability of failure to a levee, understanding the mechanisms that drive probability of failure. You're going to want somebody who's strong in understanding hydraulics and consequences. And all of that team needs to be talking and communicating, because at the end of the day, it is a risk assessment for that product. And the more people communicate, the more cross collaboration that's happening, the better that risk assessment is going to be. And then finally, bringing in the local sponsors, those that are integral to the evacuation of those areas, is critical to the success of this program moving forward. Funding's a big one. This is a big topic, I'm sure, for you all, just like it is in the Corps of Engineers. The idea with this screening tool is that we're not starting from scratch. We have national data sets that we're pulling information from, and we have other studies that we can hopefully pull data from, so we can use that information to inform this levee screening. Remember, the key here is that it's a screening. It's not a high-level risk assessment. It's really just a quick and dirty analysis. So the expected range within the Corps of Engineers is 20 to 30K per project. And then another important piece of this is that we're going to do this one-time risk analysis for every levee in the nation, but for the Corps of Engineers, we rescreen every 10 years, because as we know, risk is a constant. Factors lead to risk changing. Also, as development occurs in low-lying areas, risks, the consequences if a failure occurs is increasing, and the probability of that failure occurring is also increasing through time. So risks are increasing through time, changing. We need to be able to rescreen, redo this every so often, so that it's a dynamic system and that we can change our risk assessments as the risks are changing through time. With an effort like this nationwide, we have to build a lot of additional resources. Resources come in the form of help through the web interface, through an applications manual and a technical reference manual. And then there's frequently asked questions and LS levee screening tool help desk that people can email for support. Also, there's training. There's annual training on the levee screening tool provided here in the US, and all of those training materials are provided online for free. And those presentations are recorded so that you can view the presentations, do the workshops that are part of those training materials, and get comfortable with the tool. That's all I have on the levee screening tool, kind of a higher level. The dam screening tool, as Paul mentioned, is moving in this direction. We already have the components and how all the risk gets mixed together to give us a sense of the overall risk of our system. Now we just need to build these pieces into the dam screening tool interface. That's all I had. Thank you very much. And I'll open it up for questions.
Thank you, Woodrow, for the presentation. It's a lot of information. Rogério, I will give you back the floor for questions. Yeah, basically, I would like to thank because it's a very rich material with several tools that have a great potential in Brazil. And I have not commented before, but since in the United States is screening assessment it has a great potential, so I think it's a great north for us to identify whether the dams they are framed in the security policy of the country, and tools like this they are essential for us to make this screening, this initial assessment, and this to see the demands that the law is asking us to do in terms of this investment. So this is very good. So thank you so much. Rogério, thank you so much. I would like only to make a question, comment. In one of the dams in the first presentation was Ipanema Dam, and both of us we were involved in that situation at that time of a small dam with 1 million and some cubic meters, and we have the assessment that is a potential high damage. And at that moment, it was declared as an emergency because there was a function of emergency with the dam. And because of the classification, there was a preventive evacuation of dozens of families that lived in the downstream valley. But as it was demonstrated in the analysis, this is a difference for me that's always impactful between the population in risk and the number of potential loss damage. And the population in risk in Ipanema damage is around 20 people, but the number of life loss is 1 or 2. And we had over 30 to 40 families that were out of their houses for several weeks. When we were managing that emergency, the dam didn't break and they have a breach, but they went back to the houses. But this is a risk assessment because we have a big difference between population and risk that we use for classification in terms of DPA and the potential damage, and also the life loss, in which with the detailed assessment with the alert system, it tends to be smaller. But just comment that. I will go to the questions. First is Junior. He asks, how do you calculate the inundation spot, and if the cause of the damage of the breach was caused by rain, of intense rain, so this spot will increase if there is more rain, or how is it going to happen? That's the first question.
So I think I understand the question correctly. How do you determine the cause of the breach? Is that the question?
No, it's how do you calculate the inundation map if the cause of the breach is an intense rainfall event?
Oh, okay.
So does the inundation map increases with the magnitude of the rainfall event?
Yes, it should. And let me show you, I didn't really talk about that very much. But let me show how that would work. So within the inundation module, we have the ability to enter other rivers here. So in this one, for example, in Los Angeles, there's not really a well-defined river going from the dam moving south, but there is the Los Angeles River that flows along the southern edge of this boundary. So we could have a flood occurring here. We can input a hydrograph for that. And then within the dam itself, if we're modeling the reservoir behind the dam with a storage area, we can add inflow to that reservoir with a hydrograph here, and then model the spillway flow. So we know water is coming into the reservoir, it's going over the spillway, it's going downstream. All of that happens before the breach. Then the breach may be triggered at the the highest point of the inflow hydrograph, for example. So it happens sometime later, and all that's possible in the hydraulic model. So we can look at those. It's obviously a little bit more complicated, more information to consider for a flood-induced breach as opposed to one that's a sunny day, maybe seismically induced failure or a leak of some kind.
Paul, I'd like to add on to that. That's absolutely right. If you want to look at coincident flooding, flooding happening elsewhere in your system, the tools Paul just showed give you that. And then if you wanted to do a rainfall on your 2D mesh, so say you have an isolated thunderstorm that's causing flooding internal to your area, not just at the dam, but also your downstream location. You can't do rainfall on your 2D mesh directly in the dam screening tool, but what you can do that in HEC RAS. And we have an option in here, you can upload your own RAS model. And so you could create the model on your own in HEC RAS, then upload it to the dam screening tool that has rainfall on your 2D mesh. So you could get as detailed as you want with that model and then upload it. So the functionality is there, but to make it easier at a screening level, we've tried to reduce some of that more advanced functionality.
So this shows the option to import the HDF file from HEC-RAS, which is the hydraulic results from that model.
Recording in progress.
Nice. Obrigado. Uma outra
Thank you so
pergunta
much.
da
Another
Adriana
question
Burgai
from
se
Adriana
podemos
is
importar
if we can import
manchas de inundação
some
sem modelos
inundation
RECRAS
spots in the
para
ECRAS
dentro
model
da ferramenta
within
EST.
the tools to the EST, if it is possible to do that.
Yeah, I think that's what we were just showing here, that you can upload the HEC-RAS model. You can also download the HEC-RAS model that's created in the dam screening tool here. HEC-RAS and LifeSim model output will come as a zip file. Then you can bring that into a HEC-RAS desktop software version and do any changes you like to it, and then re-upload the results back to DST with the upload button here. So we're uploading some basic elements of the geometry of the hydraulic model, like the mesh and the river center line, things like that, and then the depth and velocity results as well that are used in LifeSim.
How realistic do you think that this program, this hydrogram problem is that uses to modeling, considering that generally you do not have so much data to calibrate this model for elevated fluids?
Very good question. I think the breach hydrograph is always going to be an issue for a hydraulic model. Sometimes it's more sensitive to the results than others. That's why I think it's always important to have somebody who has familiarity with dam breach modeling to do this part of the analysis in dam screening tool, because you can get results that are not very useful if you're not modeling the breach properly. So we made this tool to be very convenient and useful and easy, but it's not just pushing one button and getting a result that is good. It requires some more critical thought about what the input is doing and how the results are looking. So I think, yeah, it's always going to be an issue. We've hopefully built in some functionality to allow the user to manipulate the breach to make it more reasonable, and to provide simplified assumptions if those look okay.
and I'd add on to that it's also important because it is a screening level tool, and there are some very broad assumptions made that sensitivity analysis is critical to understanding, does the breach progression rate really matter in this situation, or does the population at risk have a big impact, or the warning time? There's a lot of factors with the hydraulic model and the entire analysis that there's a lot of uncertainty about, and being open about that uncertainty, changing these parameters, rerunning the model and seeing how that impacts the results, I think is a critical part of the process.
Perfeito. Obrigado aí, Paul e Woodrow.
Perfect. Thank you, Paul and Woodrow. Another question. Is it possible to use observed data for the model calibration?
In general, yes. We don't allow model calibration inside of the screening tools. Again, coming back to the idea that these are screening level, typically the models are not calibrated. It's, best practice when you're developing a hydraulic model to make sure that you've calibrated that model. But these are models that are typically a lower level of quality in general. And so they're not calibrated to events that have been observed. Because the events that we're looking at have never been observed in most cases. The failure of the entire dam is not something that you've seen anywhere close to that amount of water in the system before. So calibration is really difficult in general due to lack of data. And again, because it's a screening level, we're not really trying to enforce that. But you do need to be able to look at the results critically and say whether they're reasonable or not, even without that calibration. So if you have data that's useful for calibration, you can download the hydraulic model, import the observed data into the full software desktop version of HEC-RAS and do a little more calibrating that way.
Thank you. That's hoje, atualmente, não no
Thank you,
caso
sir.
de
Today,
Camará,
currently,
mas,
not in the case of
atualmente,
Camara,
é
but today,
possível a gente conseguir imagens de
it's
satélite
possible for us to get
com
satellite
ou dois
images
dias
with
depois
1
da
or 2
ruptura da
days
barragem,
after the
ou seja,
dam
você tem
breach.
o antes e o
It means
depois,
you have the
o que
before and the
permitiria
after,
justamente essas
what would allow
calibrações até
us
chegar
to make these calibrations until
em parâmetros mais
until
realistas,
you
né, para
get some
ajudar um
more
pouco nesse
realistic
processo.
parameters to help a little bit in this
É um pouco
process.
isso que o Josimar
I think this
perguntou.
is what
Tinha uma
Josimar
pergunta
asked.
do
There was a
Canale aí, mas o
question
Canale já
of
falou
our dear
que
Canali, but
tinha
Canali
sido
already said
respondido
that
pelo
it
Woodrow,
was
que
answered
eu
by Woodrow.
retirei, que era
So I
ligada
removed the
à
question that
parte
was
do
linked
hazard, né,
to
na primeira
the hazard,
etapa, a questão
the first stage,
quais quais os cenários para
about what
hazards
would be
considerados,
the
né, que serão
scenarios for
respondidos.
hazard that would be
Que é essa
considered.
última, né, Alan? Você quer falar aí?
Isso. O Erickson Galindo gostaria de saber se o modelo pode ser utilizado também para barragens de rejeito.
I would like to know if the model can also be used for mining tailing dams, which often have non-Newtonian fluids and contaminants for people in the environment in the short and long term.
You want to take that one, Woody?
I can. It's a good question. Can we do mining and tailings dams in this? And I think that the short answer is yes, but you would need to upload your own HEC RAS model, since HEC RAS has the capability of simulating non-Newtonian flow. You can develop a RAS model that simulates the tailings and then upload that model and use that for the life loss assessment and economic damage assessment. Now, the environmental impacts are not going to be something that you could analyze here in the tool. This would be primarily for the life loss and economic damage assessments. On tailings, there is some interest on our side of trying to better understand if LifeSim can be applied for tailings, and we've done a pretty big effort on the Brumadinho disaster for that. And we're pretty confident that we can get reasonable estimates if the hydraulic model is using non-Newtonian flow calculations.
Woodrow, is there a paper coming out on that study at the Canadian Dam Safety Conference?
Not that I'm aware of at the Canadian Dam Safety Association conference, but it is in the States. Is it ASDSO? I think they're presenting.
Oh, it is, okay.
Maybe, I don't know.
Acho que seria isso, Alan. Eu tenho uma pergunta.
I have a question.
Em geral, nos Estados Unidos,
In general, the
para
US,
avaliação do
in the
hazard
US,
potential,
to make this
vocês
hazard
fazem
potential
análises
assessment,
num cenário
you
do
run
ensolarado, né? Do sunny day.
a sunny day scenario.
Seria isso mesmo, né? Essa é uma pergunta.
Am I
E tem
right?
uma
This
outra
was
Yes.
one
questão
question.
que
And the other
se
question is,
vocês consideram de alguma forma a
if you
questão
consider in somehow
de dano
this
incremental. E se nesse caso
incremental
utilizando
damage
dano
hazard,
incremental,
if
quais
this
seriam os cenários
hazard is possible, what
hipotéticos aí
would be
para
the
esse
hypothetical scenarios for that,
incremento? Ou
this
não se
increment,
utiliza?
or you do not use this?
So for the sunny day scenario, we would
Para o cenário,
assume that the impacts are, okay, sorry. So the incremental life loss is the difference between the life loss with the dam operating as it's supposed to operate. So you can have some spillway flows that flood people and cause life-threatening conditions if the dam works perfectly. Above that, if the dam fails, it'll make a larger flood more rapidly, and you can have more people exposed to more dangerous conditions. That's the incremental life loss above the base life loss. So for a sunny day condition, we would assume that the base life loss is 0, and anything coming from the dam failure is incremental. For the hazard assessment, we have the option here also of, in the United States, it's our policy to run a sunny day failure without evacuation. So we have that option here, no evacuation, to compare the results and look at how life loss may be impacted that way. It's kind of a peculiarity of our regulations on that hazard assessment.
Yeah, I'll add on to that, Paul. So the DST currently is looking at a single event failure, whether it could be a single event consequence assessment, and that could be a failure of the dam. It could be overtopping of the dam without failure. We could even run it where the dam doesn't fail and it's just the spillway flows. Where we're going is in the same direction as Levee screening tool, where we look at the chance of failure and not failing for a range of loadings on the dam. So if the dam's at its normal high pool level, or if the dam's at the spillway surcharge level where it's actually spilling but not failing. So we're looking at both fail and non-fail scenarios. And then as Paul said, we're looking at that incremental risk, is looking at the risk imposed by the structure of the dam by taking the life loss of failure and subtracting out as if the didn't fail, what was the life loss? And eventually those two curves come together, right? Eventually you have a flood that's so big, it doesn't matter if a dam is there or not. And at that point, the incremental risk is 0. And that's how we're assessing it. So I guess you can do each of those individual scenarios currently in the dam screening tool: sunny day failure, non-failure, overtopping events, the failure and without failure. But where we're going is that you'll do all of those scenarios to do a proper risk assessment.
And then with those points, you can build a curve of probability and life loss.
Obrigado.
Thank you for your answer. Another question for Woodrow is that in the case of leaves, if we many km of extension, I suppose that you run scenarios from different points of that leaves, right? You make the simulations in different places for different locations, right?
That's correct. Yeah. So especially that's important for long levee systems, right? Where you could have a city on the upstream end and all farmland on the downstream end. So it's important that we assess the risk at multiple locations, not just where it's most likely to fail, but also where it would have the highest consequences. So we'll do multiple failure assessments along the levee.
Perfeito. Obrigado.
Perfect. Thank you.
Alan?
Alan?
Perfeito, acho que é isso. A gente não tem mais.
I think that's it. We don't have
Respondemos todas, né?
more questions. We answered
Então,
all of
caminhando
them.
também para
And we are coming
o
to the
horário, né? Que era até
to the
as 4
time we
horas,
have
né?
scheduled
Então,
4
acho
p.m.
que seria isso, né?
So
Ressaltar a importância aí
just
dessas
highlight the
ferramentas,
importance
né?
of
Que
these tools
estão sendo desenvolvidas e o
that
projeto
have been
que
developed
foi
and the
recentemente
project
aprovado
that
de expandir essa
was
ferramenta
recently approved
e
to expand
torná-la
the
também,
tool
talvez, no
and
futuro disponível,
maybe
mas testes
make
estão
it
sendo
available in
feitos,
a
né,
near
para isso.
future.
E eu
Some
acredito
tests
justamente
are
para você
running now. It's a
tentar
very useful
avaliar,
tool,
né,
so you can try to
esses
assess
riscos e o nível
these risks in
ainda
a
preliminar,
level,
né?
in a
Quando existem
preliminary level.
milhares de barragens
When we
envolvidas,
have
então é
thousands
importante
of
saber aquelas
dams
que
involved,
realmente
it's
têm
important for us to
risco
know
de vidas
that
envolvidas
we have
e
a life
quantificar isso
risk
também, né, para
involved
priorizar aquelas que
and
são mais
good to quantify and
perigosas, né, que são
prioritize
mais
those that
acentuadas,
are
né? Essa
the most
que é a
dangerous
questão,
one
né?
with a very strong
Eu queria
risk. This is the
só uma
point.
última pergunta,
Just
até
one
puxando pela
last
memória
question.
as
I'm
perguntas
just
até do outro workshop,
reminding the
que
questions
foram
we had in the
muitas perguntas na
previous
parte de
workshop.
hidráulica, né? Se
We
você
had many questions
recorda,
about the
né, Rogério? Não sei
hydraulic
se você ainda
part, if
tem esse
I'm not
registro, essas
wrong.
perguntas, porque
I
a
don't know
gente
if you
não
still have the
respondeu várias
registration of these questions
que
because we
foram
didn't answer
respondidas
many
hoje.
to be
Mas
answered
uma
today,
era em relação à
but one
questão
of them
da
was
resolução do
related to
modelo,
the
né?
resolution of the model.
Vocês mostraram aí que uma
Woodrow,
resolução aí na
you
ordem de
showed
3
that there is a
metros
resolution
é suficiente,
in
né?
around the
Até um
3
modelo com 1 metro
meters,
já
it's
estaria
enough.
exagerado,
Even the
já
model
daria
with
muita
1 meter
diferença.
would be exaggerated and
Qual que é a
wouldn't show
resolução
so
que
much difference.
vocês
So
usam
what would be
normalmente
the resolution
nas
or what is the
modelagens
resolution that
com
you
o
use
DST,
in
nos
your
Estados
modeling
Unidos?
in DST in the US?
In dam screening tool, we have a link to download the national data set, which is at a 10-meter resolution.
Okay.
And that has been adequate for most things that we've tried to do in DST. It's also the same data that's available in LST. A lot of people are uploading higher resolution LiDAR up to 1 meter and things like that. It tends to, though, not be a great trade-off. The model is much slower to run. It's a lot more data to store, and you're not getting a lot of extra resolution or answers in the results for that better data. The important thing, though, about the data that we are getting at 10 meters is that it's been processed pretty heavily by the USGS to do what they call hydro flattening. It's their terminology for preparing that terrain for bare earth conditions, taking vegetation and structures, including bridges and culverts, so that you have flow that goes through embankments and it's not, registering the top of the bridge deck as ground elevation, for example. So the terrain that we have available is pretty good quality at 10 meter. And that would need to be done for whatever terrain you're using, I think, in many cases. What did you have anything to add
Obrigado.
on that?
Dia vamos chegar lá, né?
One day we
Mas
will reach this point and be like you. Just an observation about this, Alan, and we didn't record this. Clay was here,
ele também esse projeto que a
and
USACE vai fazer em
this
parceria
project
com o
that
Departamento de
that
Gerenciamento
USACE
do
will make
Exército
together with
Brasileiro,
the
né? Vamos falar
Brazilian Army in civil
é
engineering,
projeto
they
assim
work
que
together, and
a
it's a
gente
project
pode
that we
pensar em uma forma
can
como é
think
algo que
in a
vai
way as it is
interessar não só
something
a
that will
ANA
be
como a
interesting
outras
not only to
órgãos
ANA and
fiscalizadores e até
other
outras
fiscalization
instituições do
agencies
Brasil
and
e
even
academias,
institutions in
porque é uma
Brazil,
forma de
in
tentar
academy,
envolver essas pessoas no
that would be a way
acompanhamento, né? A gente
to
bolar uma forma
involve
deles
these people in the follow-up,
colaborarem
to
com
think about in a way so they could collaborate with all these
com a
movements
USACE,
together with
principalmente nessas
USACE and
bases de
ANA,
dados, né?
mainly in this
Para tentar ter essas
database,
bases,
to try to have
algo
this,
parecido com o que a
to have
USACE
something
tem nos
similar
Estados
to what
Unidos,
USACE has in the US
que a
today.
gente às vezes tem, mas o
And maybe
acesso não é
sometimes
tão
we have,
fácil, né?
but to
Por
access this
facultação da
information is
Casa
not that
Civil, da
easy.
Presidência da República,
Have the support of
pelo
the
Ministério de Segurança de Barragem,
Republic
a
presidency
gente lá e
also,
tentar criar um arranjo que
and try
facilite
to
isso, né?
create some arrangement to
Mas era
facilitate
só
it.
essa observação aí.
It's just
Não, bem
a comment,
lembrado,
an observation.
inclusive,
It's well reminded.
nós convidamos, deve estar presente, assistindo também,
We
mencionar a presença
invited,
do
must
Coronel
be here.
Alexandre e a equipe que
Colonel
recebeu os
Alexandre
ACE,
is
que
here.
está
The team that
aí
received the USACE and is here
discutindo possíveis acordos aí
discussing
nessa
possible
área,
agreements in
né,
this
que é o
area
Departamento de
also.
Engenharia do
This is the
Exército Brasileiro.
engineering
Mas o
department of
Woodrow,
Brazilian Army.
eu acho que queria falar
But I think
sobre
Woodrow
essa
would
questão
like
de
to
resolução
say
e eu
something about this
cortei Woodrow,
resolution things, and I
passando para
interrupt
você a
you.
palavra.
So now you have the microphone, please.
Yeah, I think that sounds really great to get more people together. And one of the things, as I was listening to Rodiero, is that I was reminded when we started trying to gather these national data sets for our efforts. The National Structure Inventory is a major one, and it's been in development now for almost 10 years when we started. But when we first started, it was surprising how much data is out there nationwide that nobody knew about. That's in a little echo chamber in a university somewhere or at a government desk. So getting the groups together in having a small team actively trying to find these data sources and pulling them into a single place, it's been hugely beneficial for us. I can imagine it's going to be greatly beneficial for you as well.
Sim. Certamente, Woodrow. E só uma
Surely.
pergunta também aqui,
And another
Rogério,
question
o Gilberto Canale, né, nosso
for
colega aí, que
Gilberto
batalha no setor há
Canali, that
tantos
is our
anos,
colleague
destaca a
and is
questão da
working in
facilidade
this
de
department.
acesso
He's
aos
highlighting
materiais disponíveis no site do USACE,
the
né, que foi
way to
mostrado aqui.
get, how
Inclusive
easy it is to get
treinamentos,
all the data
manuais,
in the USACE
exploráveis
website,
para
and all manuals and trainings
pesquisarem
are
lá
also viable there, so you can
entenderem
research
mais, né?
if you want and
E o
learn
Júlio
more,
Mendes
even more.
pergunta
And Julio
se
Mendes
para
is asking
realizar os
if
cálculos,
to make the
simulações no
calculations and
software, é
simulations in the
necessário
software,
muito poder
if it
de
is necessary
processamento
too much
do
processing
computador.
power in the computer.
Ou,
This is for Paul.
Oh, I didn't really make a strong enough point about that, but these web-based applications don't require any processing power on your own computer. The interface is through the internet. You're entering the information there. If you were to do this model on your own computer with HECRAS and LifeSim, some of them can be very large and it would require significant resources on your computer for the desktop version. But we're doing all the computing in the cloud, which means we have a rack of servers that are dedicated to running DST and LST calculations, and they're shared use across the two platforms for all of the users. So all of that heavy lifting of the calculations is being done on a server somewhere else.
Muito bom, muito bom. E uma observação que
Very,
apesar
very
de
good.
ser
So
um
another observation
screening
is that
tool,
even being a
ferramenta
dam
muito poderosa
screaming tool, this is a very, very
utiliza o
powerful tool
2D,
and
né?
use
E,
HackRAS
portanto,
2D
pode fazer também
and
simulação até
can
de
also make
planos de ações de emergência,
even
eu imagino, né?
emergency action plan
Mas assim, apesar de que o principal aqui é o screening
This is what
tool,
I
né?
think, but
Ferramenta de triagem, mas
even being
você
this,
também
we know
ela
the main thing here is the
tem
screening tool,
HackRAS por trás, né?
but we also has this HEC-RAS behind in the background.
Sim. Eu acredito que sim, até para confirmar, pô, uma pergunta. O
I believe
DST,
so. Even
ele
to
tem
confirm
também
this, I
o
have a
Life, as
question.
simulações do Life
Does
Sim
DST
embutido?
also have the
Ou
simulations
só
for
modelo
life
hidráulica
scene
2D?
on it, or is just hydraulic modeling?
Yes, the LST and DST both have the connection between HEC-RAS, hydraulics, and LifeSim for the consequences. They're both using those under the hood.
Então seria possível usar para simular, por
So
exemplo, a
would
evacuação
that be
de
possible to simulate
pessoas,
evacuations of
tempo de
people
resposta,
and
sistemas de
response
alerta, por
time,
exemplo, né?
alert systems, for instance, right?
Yeah, so as I mentioned, within the web application, there's limitations, right? We're putting some guardrails on what the user can do to facilitate a rapid risk assessment. So we are allowing them to model the warning and the evacuation of people, but in the full desktop version, we can do an evacuation by vehicle along the road. We can track every person as they're moving from their starting point to a destination of safety. That's possible in the full version of LifeSim, but in the DST LST, that's not a possibility.
Ok.
Perfect.
Perfeito, Rogério. Acho que era isso. Cumprimos aqui todas as
Perfect,
perguntas.
Rogério.
Da
I
parte
think
minha,
that's
só
it. I did
agradecer
all the questions
novamente
from my side. Once
ao
again, I would
Paul,
like to
Woodrow,
thank
pelo
you,
tempo,
Paul, and you,
todas as
Woodrow,
informações
for
passadas,
all the
pela
information you
parceria
shared
com a
with us and
USACE.
for the
Agradecer o
partnership
Clay,
with
a
USACE.
Gabriele também aqui
Also,
por
thank you,
todo
Clay, Gabriela,
treinamento, todo esse
for
desenvolvimento
all the
funcional que a
training
gente
and
tem
all
feito.
this functional
Rogério,
development that we have done.
Também, Alan, agradecer.
Also, the same thing.
Vamos ter ainda outros
You both,
suportes
I
aí
believe,
com o
we use
Woodrow e com o Paul aí,
their meetings
desenvolvimento
in the future
do piloto do TST para o
because of
Brasil.
the
E
development of this pilot
agradecer também
project
os
in Brazil. And
participantes.
once again, thank
E aí, o
you, Paul
certificado,
and
quem
Woodrow,
quiser, por favor,
and the
encaminhe.
audience. Thank you once again,
Thank you
Paul
very
and
much.
Woodrow.
Thank you also
everyone.
very much.
Thank you all for being here.